Learning Intention 1, Introduction to Probability. So today we're going to be starting a new topic called probability. This particular topic, it occupies a completely different branch of mathematics to what we'd been studying before. In the previous topic, we were looking at indices, which is more of a pure mathematics or looking at number systems. In this instance, we're looking at a branch of mathematics that probably receives the least amount of love amongst all branches of mathematics, but funny enough, it's actually one of the most useful branches that you can use, or one of the most useful tools that you can put in your mathematics toolbox. Now, probability is, you could say, the study of data and prediction of the likelihood of events. So pretty much, if you're working in a profession that looks at real-world data, this is actually an integral mathematics tool that you just need to know to do your job properly. It's used extensively in areas such as computer science. It's used a lot in engineering, mathematics, physics, or pure mathematics, I should say, physics, economics. Pretty much anything that looks at data, you'll need statistics or probability to be able to do your job effectively. Now, to jump into the topic, we'll look at two examples, but we won't solve it just yet. So, example 1, Bill flips a coin 10 times. 3 out of the 10 coin flips landed on tails. What is the likelihood of the next coin toss landing on tails? And example 2, Jill throws a dice 9 times. The results can be written as such: 4, 2, 3, 5, 6, 3, 2, 1, 6. What is the likelihood of the dice landing on a number above 2? So, as I mentioned, jumping into probability, we're going to try and get some tools that will help us analyze these sort of questions that we just saw. So before we go into that, let's look at the definition of probability. So, in accordance to Khan Academy, probability is simply how likely something is to happen. Whenever we're unsure about the outcome of an event, we can talk about probabilities of a certain outcomes, how likely they are. The analysis of events governed by probability is called statistics. So, if you'd like a more in-depth look at probability, you're more than welcome to go to Khan Academy. Follow the link just at the bottom of this page here, and it will take you to the Khan Academy website where they've got an even more in-depth look, a more basic look at probability, I guess. More in-depth, we'll say. Now, jumping over to what we're doing today, we're going to add experimental probability to our mathematics toolbox. And to do that, we're going to learn about 4 different concepts. So the first one being the number of trials. So you could say that this is the amount of times that you repeat an experiment, or you could say it's the amount of data points that you have in your set of data. So say, for example, if you're doing an experiment in science, your data or your number of trials would be the amount of times that you ran the experiment and got a new piece of data from it. The second part is the outcome. So what sort of results could you get from a particular experiment? In the case of tossing a coin, it could either land on heads, could land on tails, or you could flick it and the coin could run off and you wouldn't know what it is. So you could say it's also inconclusive. And secondly, frequency. So how often does or has something occurred? So in terms of flipping a coin, let's go up. So in terms of flipping the coin in the first example, so 3, the coin landed on tails 3 times and there were 10 coin flips. So you could put a bit of conjecture and say that so long as none of the coin flips were invalid or the coin didn't run away on any of the flips, you could say 10 minus 3, which would be 7. That would be the amount of times the coin landed on heads. And finally, we're going to learn about relative frequency. So The relative frequency of an outcome is the frequency of that outcome expressed as a fraction or percentage of the total number of trials. So, putting that all together, we've got a formula: relative frequency equals frequency divided by number of trials. Now, in this particular video, I'm going to refer to everything by shorthand. So relative frequency, we'll just say that is RF. Frequency, we'll call that F. And number of trials, we'll call that N. So I'll use that sort of notation just so it keeps everything a little bit shorter. Now, going back to example 1, Bill flips a coin 10 times. 3 out of the 10 coin flips landed on tails. What is the frequency and relative frequency of landing on tails? Well, using relative frequency equals frequency over a number of trials. First we'll get the frequency and then we'll figure out the number of trials. So, Bill flips a coin 10 times. 3 out of the 10 coin flips. So, 3 out of the 10 coin flips landed on tails. So F is equal to 3. Now, how many samples did we get? Well, we flipped the coin, or Bill flips the coin 10 times. So the experiment was run 10 different times, so N equals 10. And then calculating the relative frequency. So RF equals F over N. F equals 3, N equals 10. 3 and 10. Thus the relative frequency is equal to 0.3, or as we said here, we can express it as a fraction or we can express it as a percentage. So I reckon a percentage would be a good idea. So 0.3 can be converted to 30%. So the relative frequency is 30% of the time the coin has landed on tails. Now going on to example 2. Jill throws a dice 9 times. The results can be written as such: 4, 2, 3, 5, 6, 3, 2, 1, 6. What is the frequency and the relative frequency of a dice roll above 2? So firstly, how often does the dice, or has the dice landed above 2? So in green, I'll highlight 4, as 4 is greater than 2. I'll leave 2 because 2 is not greater than 2. 3 is greater than 2. 5, 6, 3, not 1. Sorry, not 2, not 1, but 6. So the frequency thus far of the dice landing on a number above 2 is 1, 2, 3, 4, 5, 6 times. And the experiment was run 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 times. Or simply here, Jill throws a dice 9 times. Now the question at hand is, what is the relative frequency? So RF equals F over N, which can be written as 6 over 9, which is 2 over 3. So the relative frequency is 2 over 3, or can be 66%, because 2 over 3 is 0.6666, or I should actually write 67%, because it's roughly 67, not 66. So, looking back, what we've learned is we've added frequency, relative frequency, and I suppose identifying the number of trials to our toolbox on or on working with probability. So what I would like you guys to do is, if you're working from home, to cement your understanding on this little section here, I'd recommend in Hazy chapter 15a, have a go at questions 1, 2, and 3. This shouldn't take too long. It's only a small section, maybe about 10-15 minutes worth of homework. And what this will do is it will help you remember and understand the concepts of frequency, relative frequency, and number of trials. Now, if you're working from school, it's still a good idea to have a go at these questions, but the activity for today is we're going to play a game. And the game is calculating the experimental probability of a ball landing within the cup. So the way in which this is going to work is I'm going to give you some ping pong balls and some cups. And you're going to stand 2 meters away from the cup, and you're going to try and throw the ping pong ball into the cup. However, the rules are that the ball has to bounce off the table at least once. Now, to make this particular game meaningful, what I'd like you to do is I want you to record the results for each person, and I want you to calculate the relative frequency and the frequency, or I should say, I want you to calculate the frequency, count the frequency of the ball landing in the cup per each individual person. Then I want you to count the amount of attempts that the person has had, and then calculate the relative frequency of the person being able to throw the ball and get the ball to land in the cup. At the end of the lesson, we can have a comparison of who is the champion ball thrower at getting the ball in the cup and who gets a wooden spoon. So, guys, please make sure that you're recording the results. Otherwise, there's not a whole lot of worth in this exercise. So, let's get to it.